What's up guys, Harsh here. So my workspace is a bit cluttered now, sorry for that. So in this video I'm going to show you how you can control an LED, which is right over here, and this can be in any electronic device as long as the relay module can handle that. So you cannot run ACs off of this small relay, you will need a higher wattage relay. So in this video I'm going to show you how you can control an LED with your smartphone and as well as with a switch. Let's say your internet packs runs out or whatever, you can have manual control over your LED or electronic appliances. So this will come in very handy if your internet connection is unstable or it gets disconnected. So without further ado, let's get started. Okay, for this project I am using the ESP8266 module that is on a NodeMcu. So I have mounted the whole system on a breadboard to make the connections a bit easier, but breadboard is optional in this case. You can directly just take the jumper wire and stick it into these pins over here and that should work fine. Now for the relay module I am using a 4-channel relay module, so we will be able to control 4 different appliances with this relay module, and the connection is basically same for a 2-channel or a single channel or more than 4-channel relay. So you just basically need to add more buttons in the Blynk app, and as you can see that there are 6 pins over here. So 2 are for the power, the ground and the VCC, and the 4 are for the digital inputs of each individual relay, which is obviously 0 and 1. So we will connect it to the digital pin outputs of the ESP, and here as you can see are the power terminals to connect it to the main appliance. Now I'll be using this simple LED 4 LED configuration over here. So the red wire is the positive LED wire and the black wire is the negative LED wire. So as you can see I've connected wires to it as well. So this is basically a demo on how you can connect the LED or whatever appliance you are using to the relay channel over here. So now let's do the connection. So first off, let's start with our ESP module over here. So let me take some jumper wires and let's connect the D0 pin, which is this pin over here. As you can see it is written D0. Let me just flip it upside down. As you can see D0, D1, D2, D3, and it goes up to I think D8. So just connect the first 4 pin, that is D0, then connect the D1 pin, then D2, and then D3. So we have 4 individual wires coming out of the ESP module, so that way we can control our 4-channel relay module. So on the relay module you can see that there are 6 pins in total. They are namely ground in 1, in 2, in 3, and in 4, and VCC. So we'll connect the digital output pins of the ESP to the in of the relay module. So let's connect our D0 to in 1 like so, and then our D1 to in number 2, then D2 to in 3, and then finally D3 to in 4. Now you can just keep this wire somewhere else and bunch it up or whatever you want to do, so to make it a clean project, but I like to just keep it just like so, just for the sake of this video. Then we will connect our VCC, which is the leftmost pin over here, to the voltage in of the ESP, which is this pin over here right next to the ground. So let's connect it over here, and then obviously we'll connect the ground of the ESP to the ground of the relay channel module right over here. So once this is done, the connection between the relay module and the ESP is done. Now we can go ahead and connect our appliances with these terminals over here. Now in the relay module you can see that there are a total of 6 connections per relay. So there are a total of 4 relays, so we have a total of 12 connections. So let's just go through one and that will explain all the others. So as you can see that here is the middle pin of this relay. So this middle pin is actually the common pin of the relay, so this you will need to connect always when you are connecting any appliance to. Then we have a normally closed and a normally open terminal. So the normally closed terminals means that if you connect the appliance and these 2 pins will act as a switch, the current will flow and the appliance will remain turned on. So the normally closed means if I connect the appliance between these 2 pins, the current will actually flow through the circuit and the appliance will turn on whether or not the relay is off or not. So as you can see it is indicated by over here with this line over here. As you can see that these 2 pins are actually connected in this line, and it's just a simple paint, it does not have any wires, don't mistake it with that, it's not actual. So then we have a normally open pin over here, which is signified by a break line. So as you can see that there is no actual connection on this terminal and this terminal. So this is the type of connection that we are going to use. So this means that if I connect the appliance between these two pins, the current will not flow until I turn on the relay. So that's the type of configuration that we normally go with. But if you want the appliance to be always on and only turn off when you require so you can do that by connecting between these two pins. But I'm going to just simply connect some LEDs and I don't want them to be always turned on, so I will just connect it between these two pins. So let's do that. So first we will connect the power inputs to the middle pin, because those are the common pin and you should always provide power via the common pin. So let's just do that. Okay, so as you can see, I have connected the wires to the middle pin of each of the relay terminals, and then from this side just twist them and connect them with each other so that we have a common power source going through the middle pin. And then we'll connect our LED wires, the positive input, because it is obviously a positive supply, to the left pin of this middle pin. So if we look at from this side, the normally open pin will be this pin, the left side pin. So in this condition, this will be this pin, this pin, this pin, and this pin. Okay, so as you can see, I have connected all 4 LEDs to the left terminal of the relay module. So now you can just connect all the ground of the LED together and all the positive of the relay wires together, so that we can have a 2-terminal system. So from this side we will supply our positive power and the ground will go through these wires. Okay, so as you can see, now all our connections are done. So I just wired these together and this will go directly to the battery or the power source that you are using. Same with this red one wire over here. So now let's connect our ESP to our computer and let's program it and run it. And don't worry about the power source, we will be using the USB port and it will be connected to a laptop or a power bank to power the ESP as well as the relay modules. So you don't need to provide any external power to the ESP or the relay module, but to make sure that this jumper pin is in place. So as you can see that this yellow jumper pin, so this basically means that it's drawing power from these 2 pins. So do not remove this, or if you have, just put it back together or just solder this together or whatever. Just make sure that the current is flowing between these 2 pins. So let's head over to our computer and program the ESP. Okay, so now we can start with the coding, and before we do anything, first of all we need to make sure that our Arduino IDE is capable of uploading codes to the ESP. So first of all, what you have to do is just go to files and click on preferences, and in the additional boards manager URLs you have to copy and paste this link. So this link is in the description, you can copy it from there, and once you copied it here you can just click on OK. Then what you have to do is go to tools, then go to boards and select boards manager. So here is the list of boards that you can install additionally, and the list will be updated every time you open this up. So let's scroll down at the very bottom. So you will see the ESP826 is by ESP826 community version 3.0.1, and this is the particular version that I will be using at the time of this video. So as you can see that it is currently installed. So all you have to do is just click on install button, just like this. It will show just like this over here, and it will install on its own. You don't need to restart or anything. So that's pretty nice. And once that's done, you can just go ahead and close this window, and then go to sketch and go to include libraries and go for manage libraries. And in this window all you have to do is just go to the search bar over here and type Blynk, then press enter. So once you press enter, you will be shown a list of Blynk libraries. So all you have to do is install the first one over here, and as you can see it is already installed in my system, so I don't need to do that again. So once that's done, you can just close the window again. And what we are going to do is just simply use an example from the library. So what you do is just go to sketch, just go to files, then click on examples, and then select the Blynk library. So here it is at the very bottom, and then we will be connecting via Wi-Fi, so we will select the Wi-Fi option, and from here we will select our board, which is the NodeMcu. So this one, so it will open up another window. Just maximize it. So here is our code, and it's pretty simple. Let me just clear out the comment line and all that. So as you can see, here are some follow-ups, and if you want to check that out, you can do that, but let's just remove it for now. Okay, so the actual code that we need to do is only this much code. So as you can see over here, so you have to change a couple of things here. So here your authentication code that you received in your mail will go, so it will look something like this. So as you can see, I have pasted my authentication code, and it will look something like this, and you will receive it in your mail when you create the new app on the Blynk app. Then you will type in your network name, so it will depend on your network type what name it has, and then the password, and make sure that network has internet connectivity, because if it does not have internet connectivity, it will not work. So you need to make sure that it has a stable internet connection, because this is an IoT project. So once all this is done, you can just go ahead and simply upload the code to the board. And before doing that, you need to select the board by going to the tools and selecting the board. So just go to boards and select the right module. So in my case, and it might be in your case, the NodeMcu 1.0 ESP12E module. So this is the most common module that most probably you will have. So just select this particular board and then just click on upload, and this will upload the code to the board. Okay, so now let's open the Blynk app and see how we can program and make an app for our relay program. So let's just click on new project, and let's just give it a name. So I will give it a name remote relay. Then we have to choose our device. In this case, we are using a NodeMcu, so we will select that, and then we will select the connection type, which is Wi-Fi, and then click on create. So it will give you this nice workspace. So all you have to do is just go to the plus button sign on the top, and here you can select different types of things that you can interact with. So let's just add 4 buttons. So each button will correspond to the relays that we are going to operate. And once you create this app, you will get an authentication code in your email from which you have registered in the Blynk app. So that will be pasted in your Arduino IDE code. Okay, so now let's program each one of these buttons. So let's just click on the first one, and you can give it a name, and I'm going to give it B1 name. So we're going to assign a pin number to this button. So let's start with D0 for the first one. So it has assigned D0 pin to it, and the mode will be switch. So the difference between switch and push is, if you set it on switch, you will have to continuously hold down the button on your smartphone to make the relay work, and in switch you have to just only tap once for the relay to function. Now like this, we will program every other single button. So let's just go to second button and name it B2. You don't need to name them, it's just something I like to do, and assign it a pin number. So it will be D1. And one nice thing about this app is that you can see that the D0 pin is already used, so it is showing used. So if you are assigning a pin that is already used, you will know. So let's just assign D1 to this pin and change the mode to switch, then go back and do the same for the rest. And once the application is done, you can just go ahead and press the play button on the top right corner, and it will start working right away if your Arduino or whatever is connected to your Blynk app. So at this point, if you have done everything correctly, you should be able to see some functionality on your relay module. So let me just turn on our first relay. So as you can see that it lights up, and there is also an LED on the relay module that lights up to indicate that the relay module is working, and that means our connection is perfectly fine. So let's just try another one. So the second relay, so it's also lights up. So let's just try the 3 and 4. So as you can see, our entire relay module is functioning pretty fine, so the project is successful. And the only downside about this project is that if it requires an internet connection, so if you don't have a stable internet connection, this might not work in your case. So in that case, you might need to build a web server for the ESP, so that the ESP has its own server connection and you can connect it to the same network as the ESP and control it without or with internet. So that doesn't really matter in that case, but still it's a pretty fun project. You can just remotely turn these LEDs on and off from wherever you are in the world, given that you have internet connection. So this was it for the relay connection. Now let's see how you can manually control the LEDs, because at this point, whether you are using an LED or electronic appliance, you are stuck with this smartphone forever. You don't have any manual controls. You cannot just touch the relay or do something to turn on the relay or turn off the relay when you don't have an internet connection. So let's see how the manual control can be done. Okay, for the manual connection you will need the same contraption, but this time I am using a single relay model because there are a lot of connection and you might get confused with all 4 relay channels. So I am using a single relay channel to show you how it works, and then you can rinse and repeat this process on all of your relays. So for some reason this relay also has a terminal on the input side. I don't know why, so I have connected this wires over here. So the red is for the VCC for the relay and yellow is the ground, and then the orange wire is the signal wire for the relay. So let's just connect it like before. So our positive will go to the VIN of the relay ESP, then our ground, which is the yellow wire, will go to the ground of the ESP, and then you can connect the orange wire, which is the signal wire, to any of the output pins. So I'm going to just connect it to the D0 pin just for the demonstration purpose. Now the main thing happen is with these terminals over here. So what we are going to use is a special type of switch. So this is called a two-way switch or an on-on switch. So in this case we have a common terminal. It's basically as same as the relay. So we have a common terminal in the middle and we have 2 terminals on either side. So when the switch is in, no matter what the position of the switch is, it has only 2 positions, that is left and right. So no matter the position of the switch, the current will flow at least within these 2 pins or these 2 pins. So doesn't matter, it does not stay off at any moment in given time. So it's just that the current will flow either with this wire or this wire when the power is coming through the middle pin. So as you can see that I have connected 2 wires to the extreme ends on the other side. So you might need to know what your common pin is. Some switches might have the common pin on this side or this side. So that is up to your supplier to show whether which is the common pin. So I know in my case the middle pin is the common pin, that is almost every time with any of the switches, and this will not work with a 2 terminal switch, so keep that in mind. So let's take these 2 wires and connect it to the relay like I have shown over here. So take these wires and connect it to the leftmost terminal. And then take the other pin and connect it to the right side pin for the terminal. So the connection will look like this, and then you can just screw that in place. So the connection will look like this. It's a pretty clean connection. Now take 2 wires and connect them to the common terminal of the relay and the switch. So just take 1 wire and connect it on the middle terminal of the relay. And then do the same with the terminal of the switch. Okay, so as you can see the final connection will look something like this. So we have 2 wires coming out from the common pins of the switch and the relay, and the other terminals are connected in parallel or whatever this combination seems like. So now you will connect these 2 wires just as normally as a common switch. So first the power will come through here, then it will go in this relay, and from there the switches will control the power of flow from this wire, and this will go to the input of the LED, and from that LED the ground will go to the ground. So let's do the connections. So here is my LED. So let's connect the positive to the positive side of this switch over here. So this is the ground of the LED, so it will obviously go to the ground of the power supply that you are using. So in my case it's a 12-volt battery, so let's just connect it over here. And then the positive volt will be supplied from this wire, so it will be connected to the positive of the battery. So as you can see that our system is not even turned on and the LED is lit. So as you can see, so we can fix that just by simply turning off this switch, just like so. So as you can see, now that LED is turned off. So let me just show you that again. Let me just keep the wires in place over here. So let's just take the switch and turn it on and off. So as you can see, the switch works pretty fine. Now let's power up our ESP. So let's just give it some USB power. Okay, so now our ESP is also powered, and as you can see that the light on the relay is working. So this is irrespective of the whether the LED. So I got my app connected. So as I have already told, it is connected to pin D0. So our pin D0 will work with the relay. So let me just turn off the relay from this side. So as you can see, relay functions just fine, and if I want to turn the LED manually, I can do that just by using the switch over here, as you can see. And if I want this light to be turned off from the remote, I can also do that. So we have full manual and online control of this particular LED. And one thing to keep in mind is that once the LED is turned on, and if you want to turn it off, the on this position will be off, and if you turn on the relay, then the position will be switched. So there is no definite on off situation in this case, but still it's nice to have a manual control. Alright guys, thanks for watching the video. Hopefully this video helps you a lot in making your IoT project, and if you have any doubts in regarding the connections and whatnot, you can just ask it in the comments. I will try to answer them as much as possible. So thanks for watching the video again. Please like, subscribe and share, and I will catch you all later.